In this course, we are going to study two mathematical models, the so-called Lotka-Volterra model, also known by the name PrePredator model, and the model of epidemics. That is a subject that we all hold dear because it's affecting our lives at the moment of this video. We will analyze these models using software. So we'll solve these models using software, and in particular, this is open source software, so that all students can download this software and use it without having to purchase anything. The software that I'm talking about is called Scilab. Scilab is a free version of MATLAB. So if you have MATLAB, you can use MATLAB, but I'm going to use Scilab because it is open source software. And in particular, we are going to need a tool that's contained in Scilab, and this is called XCOS, which will help us construct the mathematical models that we are going to solve. XCOS is analogous to Simulink. It is a free version of Simulink, which is a tool contained in MATLAB. But if you have MATLAB, you can of course use MATLAB. It is very similar to Scilab for what we need to do in this course. But if you don't have MATLAB, you can use Scilab because it is open source software. So you can download it for free just by Googling it. Now, let me say something more about these models and why we need to solve them. These models are very important in applied mathematics because they can explain a variety of phenomena. The Lotka-Volterra model derives its name from the mathematicians who first adopted this model to explain some phenomena they were concerned with. Lotka used this model to explain the interaction between two molecules. So he was interested in chemical reactions, whereas Volterra, who was an Italian mathematician, used this model to explain something quite curious, peculiar. And there is a very short story that I need to tell you before telling you what Volterra used this model for. Volterra's son-in-law, whose name was d'Ancona, who was an Italian biologist who observed something very strange that happened in the Adriatic Sea during the First World War. So he analyzed some data and he found that the number of sharks during the First World War had increased substantially with respect to the pre-war and the post-war period. Therefore, d'Ancona asked Volterra, who was his father-in-law, to analyze this problem mathematically, because d'Ancona knew that Volterra was a great mathematician, and in particular he was an applied mathematician, so he liked to apply mathematics to real-world phenomena. And Volterra took the challenge and decided to create a mathematical model which would explain why this would happen. The number of sharks had increased during the First World War. And this was a substantial increase, like 20% or 30%. So he wanted to explain this. And he managed to explain this by using this Volterra model, Lotka-Volterra model, or the PrePredator model. It is also called the PrePredator model because it focuses on the interaction between two populations, a population of prey versus a population of predators. In this case, the population of predators is sharks, whereas the population of prey is represented by preyfish. Volterra understood that the reason why the number of sharks increased dramatically during the First World War was due to the activity of fishing, because during the First World War, the activity of fishing diminished, was less intense, and that had interfered with the interaction between sharks and prey fish. So that's what he understood, but we are going to see this more thoroughly in the course. So if you are interested in this problem, we are going to do that in the course, and also the prey-predator model can be used to explain other interesting phenomena that I will mention at the end of the first part of the course. After that, we are going to study epidemics, and we will use the same concepts and the same software. Before concluding this introduction, let me tell you that the mathematics that we need in the course are not very difficult. You just need to know something about what is a derivative and what is a function. We are not going into the mathematical details in this case of how to solve a model in particular. So we are going to do something very straightforward. In principle, I could get into the mathematics of this, but I'm not going to do it in this course because I want to focus more on the practical applications that maybe are much more of interest to you rather than the theoretical mathematics behind. And I think that this is a good place to stop. I hope that you are interested in this course and that you will enjoy.